I'm Chad. I'm an architect here at Pallantier, and I'm really excited to share some cool stuff with you today in the second part of our deep dive series on the Ontology Augmented Generation, or OA. The ontology is made up of data, logic, and actions. In the previous video, we laid the groundwork about how the ontology anchors AI in the operational truth of your enterprise through the use of data tools. Today, we're going to navigate the world of logic tools. So logic tools can be ML models, optimizers, other computations that are spread across environments and power your enterprise processes. Today, we're going to combine these sources of logic with the power of reasoning from LLMs inside of AIP. So let's dive right in to see what we're going to build today. All right, AIP on your enterprise, building with our artificial intelligence platform. So let's go dive into the topics for today. First off, modeling objectives, evaluation, and deployment. So we're going to cover end-to-end MLOps suite inside of AIP. Then we'll talk about how we think about AIP as a tool factory. So using tools like AIP to build other tools to help me be a better developer, a better data scientist, and help me get my job done. Similar how I might build a robot to help me go build cars more efficiently, right? Then logic functions. So we were talking about this a little bit, but how do we take things like a forecasting model? That's a source of logic in your business. So things like a profit framework from Meta, we're going to use to actually create a logic tool that then we'll give access to through our AIP logic, our LLM-backed functions, to generate a forecast of, in our case, customer orders that will then surface back through our AIP Copilot interface in the Titan Control Tower. So, wow, that's a lot of content today, so we better get started and build. All right, quick pit stop here just to make sure that you understand how everything fits together. High level modeling objective is what the name is. It's what is the end goal? What is the objective I'm trying to achieve? A forecast of customer orders. That's what we're going to do today. It could be a classification model, any sort of objective you're trying to go after. An objective has many modeling assets. A modeling asset is made up of artifacts. It could be the model file. It could be a container. It could be a pointer to a third-party endpoint. And then you have model adapters is essentially acts as the API into those artifacts that standardizes the output of those assets in a consistent way so that the rest of the AIP tools can use it. All right, now down to how we get models in. We can train them code repo or in code workspaces with Jupyter Notebooks or RStudio. You can actually train inside on data that's already in the platform. Very cool. Or if you already have models that you've trained elsewhere, you can import those models, pretty standard. Containerized models, so we see a lot of teams packaging up their dependencies in containers. You can import that container inside of AIP and actually host on the endpoint or a deployment inside of AIP. Pretty cool. Then we have externally hosted models. So if you already got a model endpoint running somewhere in another cloud provider or a third party, or you've paid to have access to one somewhere, you can register those as a model artifact. So one modeling objective can have many assets, and those assets can be spread across those different modalities of deployment, all inside of one objective, and evaluate and test them all together. Very cool. Let's dive in and see what it looks like. All right, so this is a example modeling objective. End goal of this one is to find the probability of a machine breaking down. The real goal of any model is to put it in danger of actually being used. I see too many data science teams building models over the place, but they never get to a productive state. So we're actually going to start with the production endpoint and work our way back about how we got there today. So if we look here, we're going to scroll down through our modeling objective and we see deployment. So deployment is a endpoint that is actually hosting that model. And so you can see here we have a production and a staging. And so in a production endpoint, let's just start and look at that. What is it actually? What is it? And so this example, this is a model that we actually imported. It's on a live endpoint. So you have live or batch. So live would be something I can hit as a user and get inference in real time. Batch is going to be used in a pipeline to get a set of predictions or classifications, etc. And then you can have things like runtime configuration, so different inference profiles for the actual systems. And you can pick this based on utilization. Publish these functions, a bunch of different stuff here we won't go through. The query is pretty cool. It's like Postman for your models, so you can go play around with it, test it out, see what that looks like. Lots of stuff here. And then logs and metrics, so you can actually actively see what the logs are looking like of your model inference, and then also the performance of the inference server. So you can understand what is the load, and do I need to choose a different resource profile? Is this model and the architecture I picked congruent with what I need from a resource profile, right? Pretty cool. So we think about that from a deployment standpoint. I also have staging. So I don't usually just want to put models straight in production. I want to put them in a staging environment and maybe test out with a subset of users. So we allow you to have that CI/CD for your models. So you're going to move from a model sandbox into a staging, into a production environment, and we have the right controls and checks in place. Pretty cool that you have all that here. And it's actually quite simple to go do. So if you look here, I can actually release a model to staging. So I can pick my demo model, release to staging, and I can actually go look at what is that compatibility check, submit it, go. Or if I want to move something from staging to production, I can tag that, move it to production. Again, we have all the right controls and permissions, so it's the right users that have access to go do this. Then if we go up from releases to a deployment, we want to, well, what model should I put in staging? What model should I put in production? We need to evaluate, right? So if we think about that, in this evaluation, let's just give you a quick view. In here, you can pick evaluation data sets. So you can have one or many different data sets to test these models on. Evaluation libraries. So these give you the different metrics. So if you can see here, I have some standard ones, but I also can create my own evaluation library or bring it in. Could be your open source stuff. It could be your own custom libraries. Very configurable about bringing your own model evaluation libraries in. And then evaluation subsets, pretty cool. Think about it, if I need to segment out and make sure my model performs well in the US and the UK and Australia, I can create subsets to make sure that I'm testing that across those differing domains, right? Pretty slick. So what does that actually look like? So I'll pick my metrics here, and we'll pick model V5 against, let's see, model 17. That's a new one. So you can see this is actually that evaluation library that we have that's going across these two different models, and I can compare the metrics. And if once I've decided which one I want to go do, I could release that to a staging, test again against what have my end users do user acceptance testing. Cool, then push it to production, right? So pretty cool evaluation components here. These evaluations can be done on model submission, ad hoc, lots of different stuff you can configure in here. Then, so now we talk about evaluation. How does a model get in here? So you can see these model submissions. There's 27 different models under one modeling objective. So these different modeling assets, let's go take a look here. You can see there's quite a few. And just a quick plug here. So you have releases, so the production, staging, review statuses. So you can set up review gates of having people review them, whether it be your peers or a data science manager before, and then a business user to sign off before you release to a staging or production. And so you can see all these different models, and they're different tests that data scientists are experimenting with, submitting them, and hey, let's go. Right, so pretty cool that you have that workflow and ability to see all these different models. Then this is how we add models. So submit from Foundry. As we talked about, you could have a model asset that you've trained using Code Repo or a Jupyter Lab notebook inside the platform, bring that in here. You can train that, as we said here. You can have an externally hosted endpoint, the containerized models, or even an open source one. This is pretty cool. So straight hooked up to Hugging Face, I want to use an embedding model, go, right? So if you've got off-the-shelf stuff that's open source you want to pull in, very simple to actually bring these open source models straight into model asset, you use it. Very, very cool. So high level, that's modeling objective. There's some great documentation. We'll put the links in here, but I think you get the flavor for it. All right, so this is our checklist. We're going to knock that off the list. Next up, AutoML. All right, AutoML. So this is actually just a workshop app. This is something we created to help us generate model code more efficiently so that we can then generate models faster to deliver for the end objective quicker, right? So we're going to put the intent that I want to create a forecast of customer order quantity. I'm going to use the customer order object in the ontology, and we're going to generate code. So this is actually using AIP logic in the back end to actually help me generate the model training code that I might need, or as a starting point for me to go actually build models that I can then use towards that modeling objective. Very, very cool. So if we look at that here, I now have, oh, this is pretty cool. So now I've got linear regression, random forest regressor, and a gradient boosting regressor, and I've got the training code to go do it. I can hit start training and actually go build these models out. Again, everything inside the platform is an API, so me as a developer can create these tools to help me go do things. What does it actually look like on the back end? No magic here, it's AIP logic. Very, very cool. So the same thing you're using to create these user experiences for end users, I can create these user experiences for my team or for me as a developer to be more efficient. Very slick, I just want to share this concept, a tool factory. All right, back over, we'll mark AutoML off the list, logic functions. All right, so before we build logic tools, we're actually just walk through the use case real quick as a refresher. So I'm a supply chain analyst. This is the Titan control tower. This is what I use to navigate and look at my supply chain. We heard there was a fire in the Haynes Medical Supplies distribution center that we distribute face masks to a hospital from. Not great if we had a fire in a face mask distribution center. So we're going to start shorting customers at hospitals. They need face masks to operate. So how do we navigate this? Last time we built this copilot that would navigate the ontology and find where the customers that would be impacted, where might have enough inventory to supply out of, and go change those orders. So it gave us the list of orders, great. But it's going to take a while to recover from a fire. So how are we going to manage this in our supply chain? We probably want to forecast out a longer period of time of customer orders so that we make sure we have inventory in the right place at the right time so we don't short these hospitals the masks they need. So that's what we solved last time. So we're going to add in this logic function for forecasting. What does that look like? So here's a quick diagram. This is actually Solution Designer. This is actually another tool inside of the platform. And we have me as a supply chain analyst. I have a workshop app that was the Titan control tower. We last time had created this supply chain copilot backed by AIP logic. It navigated the ontology, so grounding the LLMs in the truth of our business and our enterprise with the ontology. It's great, but we want to add in another tool, logic tools. And so in this case, we're going to create one that says forecast customer orders. It's going to have access to the ontology to get historical customer orders to use for a forecast. And we're going to have a new modeling objective that's going to give us around time series forecasting. So we're actually going to use Meta's profit framework to create an additive regressive model that will actually take this input time series data and give us a forecast out on the fly. So we're going to have to create this modeling objective and create these adapters and these logic tools. So just a good frame of reference of what we're going to go build here. All right, so we have a time series forecasting objective here. You can see these were actually from the AutoML piece that we did prior here. So I've already got these models, but I decided I wanted to use this live endpoint of Profit Meta because I think it's great to show that I actually can have a live endpoint training this stuff on the fly called by LLMs. I just think that's pretty neat. We've got a deployment that we've already pushed out. So this is a live endpoint of the profit model that we're going to go use, but now I need an adapter, right? So what does that adapter look like? That adapter is pretty simple here, not too much to it. I've got an API. This is the input. So DS in the profit framework is for dates. Y is the quantities. So that's my input. So just a time series of dates and quantities. And the output I get is, again, DS for dates, forecasted quantity, upper lower bounds of confidence. I get that back out as a data frame. And then you can see here, just to call this out from like to run inference on different models, different model architectures or frameworks, I might have to call that differently. Again, this is why we have the model adapter. So I'm actually going to take the input, a time series data set. I'm going to run the profit.fit on that time series and get my data frame out, map it, and write that back out. So that's actually what a model adapter is, not super complex. Then I need to use it, right? So if we come back here real quick, I've got an objective, I've built my adapter. Now I need this logic tool. And so if we come back over here, I'm going to have my forecast customer orders. That's going to take an input of orders or order primary keys. I'm going to output a forecasted quantity. So I'm going to take that in. I'm going to create an object set, the ontology object set. I'm going to actually group by. So these are native ontology functions. So I'm going to take that object set. I'm going to group by because I might have more than one order on a day. As you saw in the adapter, I need one day and a quantity for this time series. So this is where I'm actually creating that time series of a day and quantity across these different orders. And then I'm going to put that into our time series, map it into the format that our profit adapter needs. And then this is where I actually call that live fit.profit. That's the adapter.transform. I input that time series, 14-day forecast window. I'm just hard coding it for this example. I'm going to take the output, and for our LLM use case, I actually just want the total forecasted quantity aggregated. So this is where I'm just going to map out and aggregate those, the array or the data frame output into a single value, and I output that as a double. So that's as easy as this function is. You can see here, We can actually play with this one live. I'll throw in a set of primary keys from our Titan customer orders and hit run. Pretty slick. So now that's the forecast quantity for the orders that I just put in for the next 14 days. Very slick. So you can see how now if I'm an LLM and I have access to this tool, I can pass in orders and I get a forecast in just a few seconds. You can see the performance here. Some of it was the object aggregation, some of it was the model inference, but you can quickly see how this performs when I'm going to call this from our LLM function. All right, so we finished building the logic tools. Next up, we're going to actually integrate those with LLMs. All right, so AIP logic is our LLM-backed functions. So you can see here, this is for the same flow we had last time. We're going to do entity extraction. So based on our prompt here, I wanted to find the finished good, but find the actual finished good of my business. So when we talk about anchoring AI in the truth of your business, this is how we do it. We use these data tools to search the ontology to find the finished good from this prompt. So it's doing that entity extraction, searching for it, finding the actual surgical mask finished good. Same thing with distribution center here. And then where this all comes together here is this last logic block. We have access like we had last time. These are the data tools that had access to. And this is the intent. We're going to be a supply chain helper agent, and we're going to find new places to distribute that has sufficient inventory. So that's the intent. And then we added a few things. So the calculator tool, because we're going to do some math, and then the forecasting customer orders logic function we just built. And when we add that in here, you can see I added some examples as well. So this is giving the LM an example about when and how and when it gets back when it calls this function, so it can reason about how it should use this as a tool. Very cool. So now I bring it all together, and it's actually going to go find the customer orders for this plant and these finished goods, and then it's going to follow this step. So these are the kind of steps I might tell an analyst that I'm training. So similarly, think of when I'm doing this prompt engineering in AIP logic, as I'm teaching an analyst, I'm teaching a person on how to go do this. So I'm going to find the order quantity per plant per customer to calculate the total, so I understand the orders that are going to be impacted at the plant that had the fire. And then I want to go create the forecast. So I'm going to pass those orders in to my forecasting tool so that I can go then generate a 14-day forecast. This is where the LM reason that I should use this tool. And then it's going to go through and put all that together and give us an answer about what it thinks we should go do to solve this problem. So if we hit run here, we're actually going to see this live. So this is our debugger, and this allows you to see the actual chain of thought reasoning to debug these different logic blocks and what's going on. So it found the right finished good. Now it's finding the facilities, and it's using the ontology to actually back all this and grounding in the truth of our enterprise. So now it found the Haynes Medical Supplies, and now we're down to the last block where it's going to find all the customer orders that are impacted by the finished good and the distribution center that it found. And here's all the impact of what those are. So you can see as we're going here, I can now navigate and understand what this tool is actually going and doing. And so if we keep scrolling here, we just called the forecasting function. So we passed in right here, we passed in all the orders that were impacted. It gave me a forecast back. So there's our logic function to build a forecast in real time, generating forecasts triggered by an LM using the ontology. A lot of stuff coming together, but very, very cool that I can ground this AI function in the truth of my business, both through the ontology, but now, LMs are very stochastic and you have hallucinations. I can ground it in truth of maybe a forecast model that I trust more to do a really good forecast, right? So as we have those things across your enterprise, you can leverage what you already have today and use that to build these AI functions. Very cool how this all comes together. All right, so we completed this. We've integrated the forecasting function models into our LM function in AIP logic. So let's go use it. All right, so we hit publish. It's going to publish that AIP logic function, and we're going to go back to our Titan control tower, which is built in Workshop. Again, our low code, no code offering. So we're going to come in here and actually update to use version 14 that I just published for that. And for our chain of thought reasoning, we're going to do the same. Just a quick call out. You can see here I'm on the main. I could have branched this out and had a subset of users go test it before I push out this change to use the new version to everyone. So branching and merging across the entire platform. We're going to just use the one on main here today. When we hit view, let's go back and try it using our new function. So if we click this, we're going to go. And so now this is going to take this intent, figure out which tools I should go use. In this case, we've given access to the supply chain tool that we just updated to the new version, right? That has access to the forecasting tool. So you can see it's already going to use that tool. It's showing the chain of thought reasoning. And now this is similar to what we saw in our AIP logic debugger. It's going to do the entity extraction for surgical masks. It's going to do the same thing for distribution centers. So think about me as an analyst. I see what's going on. I have this complete visibility. This isn't cutting me out of the loop. This is really human in the loop AI, us working together to get things done more efficiently. I can even go navigate, I want to go look at this order or that order. It gives me that visibility of the chain of thought to actually go look at what it grounded the truth in the ontology. What objects was it looking at? Let me go investigate. You have that complete visibility here, also to what tools, and you can see as it's using these tools what it's doing. So great example, running the function. Here's our forecasting tool we just added in. So LMs are great at a lot of things like reasoning. They're not great at forecasting. They're not great at different types of math. So we use the right tool for the right problem. And so if you already have tools across your business that are doing different optimizations, forecasts, different types of math that are important to you, you can build these tools and integrate them to add the power of reasoning from LM and AIP logic with these more deterministic tools or less stochastic tools, we can say, across your enterprise. So you can integrate things you already have across your AI journey here and have that complete visibility of when are you using them. So from an analyst, I can really start to trust what's going on here. I have this complete visibility into the chain of thought reasoning, what tools, what data I use to do it. This is very, very cool. I actually used an LM to call and create a forecast and use that forecast output to do something more intelligent in my business. And I have that visibility as a user. This is really cool. All right, that's the content for today. In the theme of data, logic, and actions, the first video was on data tools. Today was on logic tools. The next will be on actions. How do I close the loop and have LLMs actually take actions to change these orders for me with my oversight? That's really what human AI teaming is all about. Hope you enjoyed building it today. See you next time.